Welcome back. So now let's go on to topic 2, which we're going to solve multi-step equations involving a single logarithm. So let's jump to example 1, and I'm going to be using the steps to the right. So maybe I'll make it a little bigger. Easier for us to see. Okay, that's just the steps. I don't think we need to see that. I think it's more important to see all the words in the steps. So for step 1, we want to isolate the logarithms on one side of the equation. So in our case, we only have one log, so it's already to the one side. So step 1, done. Step 2, we want to write a sum or difference of the logarithms as a single logarithm. Again, we already have a single logarithm, so step 2 is done for us. So step 3, we want to rewrite equation in step 2 in exponential form. So since these are already done, then we're just still looking at our original equation. So we want to rewrite this in the equivalent exponential form. So to do that, so this is going to be 6 squared is equal to 5x minus 4. Right? And then step 4, we're just going to solve for x. Right? So remember, I'm going to use an arrow because there's an equal sign right here. Okay, so 6 squared, we know that is 36 because 6 times 6 is 36. And then we're just going to bring the rest down. I want to get x by itself, so I'm going to add 4 to both sides. When I do that, I get 40 equals 5x. Okay, so x, not only do we want it by itself, but we want it to have a coefficient of 1. In order to do that, we're going to divide both sides by 5, or you can multiply both sides by 1/5. It's same thing. So when I do that, so if I divide by 5, I get, not 5, this is 8 is equal to x. Right? So we get 8 equals to x, so we have one more step, and we want to check all the solutions to verify that they are within the domain of the logarithmic expression in our original equation. So what are we going to do? So step 5, okay, I have log base 6 of 5 times 8 minus 4 is equal to 2. Right, so log of 6. 5 times 8 is 40. 40 minus 4 is 36. Right, so 36 is within our domain. So you could actually stop there, but let's actually see if this is correct, because even though it's in our domain, doesn't necessarily mean that we solved this correctly. So 36, I know that 36 is also 6 squared. Okay, and then using the power property, I can actually bring this over. Actually, we don't even need to use the power property. What property is it? Property 3. So if I have the base, and then it's times the base to the power, so the same number as the base to a power, then this is just the power. So then I get 2 is equal to 2. And this was by property 3. So this is true. So not only is our equation true, but the domain is also good. So what does that mean? That means x is equal to 8. Right. So now let's do another example. Right. So this one, so example 1 was a little straightforward in the sense that we just started with step 3, but now we have to take a few steps more before we solve it. So we want to isolate the logarithm to one side. So essentially what that means is that I also want all these numbers, like I want all these coefficients and stuff to go away. My goal is to get this by itself. Right? So how do I do that? So essentially I'm treating this as if it were like y, like solving for y. So in order to do that, I'm going to add 4 to both sides first. When I do that, I get 6. Okay, there's still a 3 here. I could put this 3 up here, but then we would have to find x plus 7 cubed. I don't know about you. I don't want to do that. Right? That is gross. Well, it's not gross, but it's just, so much work. So in order to lessen our work, what can we do? We can divide both sides by 3. So then I'll get log base 2 of x plus 7 equals to 2. Right? Now that we're here, right? So there's nothing else I can do. There's no sum or difference we can do. So we've isolated this. So now what do? Remember, our goal is to find x, but in order to, I can't find x as is, so let's rewrite this in exponential form. So this is equivalent to 2 squared is equal to x plus 7. Right, and now we're just going to solve. So I get 4 is equal to x plus 7. Subtract 7 from both sides. I get negative 3 is equal to x. Right? So we see that x is equal to negative 3, but do not be fooled. So this x is not the same as this x. All right? This x represents the entire argument. This x just represents part of our argument, because our argument is x plus 7. So just because there's a negative here doesn't necessarily mean it's not in our domain. We still have to plug it in. So the very final step, we're going to check. Right, so I get 3 and then log base 2 of negative 3 plus 7 minus 4. Is this equal to 2? Right, let's get some more space here. Right, so then I get 3 log base 2, negative 3 plus 7, that is 4. Okay, and so 4 is within our domain, right? So that's a good sign. So it's positive, and actually that's all we need, it's positive. So this is great. But now let's take it a step further, and we're going to check our entire work just to make sure we did our work correctly. Okay, so 4 can be rewritten as 2 squared. Okay, I'm going to use, I'll still use property 3. So this log base 2 of 2 squared, that becomes 2. Right, this was property 3. And then we get 6 minus 4. Is this equal to 2? And what do you know? 6 minus 4 is 2. So this is equal to 2. So what does that mean? That means that x is equal to negative 3. Right, and that is all. So now the next section that we're going to be talking about is the natural log. So see you in a little bit.